Hello, welcome. In this video, we're gonna go over momentum practice question. So the question is saying a bullet of mass 10 grams and traveling at a speed of 500 meters per second strikes a block of mass 2 kg which is suspended by a string of length 5 meters. The bullet goes through the block in a very short time and the center of gravity of the block is found to rise to a vertical distance of 10 centimeters. What is the speed of the bullet just after it emerges from the block? Okay, so before we do anything, let's try to check if at all the units are in the standard form. So as you can see, the bullet, it's here. Okay, the bullet is here. Let me use different color. Okay, so the bullet, it's here. It was moving with a velocity of 500 meters per second. So now the bullet has 10 grams as the mass. So we need to convert the mass to the standard. So we can say the mass. So we say data. The mass of the bullet it is 10 grams. 10 grams. So now let's convert to SI units. We know it's just to multiply by the conversion factor, of which we can say 1 kg is equal to 1000 gram. Okay, so if you compute that, what is it giving you? So it's giving 0.001. Okay, kg. So that's the conversion. So we can put that the mass of bullet is 0.01 kg. Okay, so then the speed, what's the speed? The speed is 500 meters per second. So initial speed, we can say it is 500 meters per second. Okay, so then what about our block? Our block, as you can see from here, it was at rest. What was the initial speed? The initial speed was 0 meters per second. Okay, what about the mass? The mass is 2 kg. That's the mass. Okay, so then after this block strike this object, it rises to a certain height, of which they are saying it is 10 centimeters. As you can see in the question, it is 10 centimeters. So it rises to 10 centimeters. 10 centimeters. Now it's not in the standard unit. Let's convert it. So we say the height is 10 centimeters, but we need it in a standard form, of which we can say 1 meter is equal to 100 centimeters. So if you convert that, you find that 0 and 0. So you find that it will be 0.1. Okay, so our height, we can just say it is 0.1 meters, and we ignore this one, which is not in the standard form. Okay, so now let's go back. Have we converted everything to the SI unit? Okay, the standard, everything is in standard, so we can erase this thing to create some space. Okay, okay, so now let's try to look at the situation here. This is momentum. So what can we say is conserved here? We can say that momentum is conserved. How? Okay, let's try to look at the situation with a formula. So we can say, if we say momentum is conserved, we are saying m1 v1 plus m2 v2 should be equal to final m1 v final plus m2 v2, which is a final. So let's take our bullet to be our object 1. Let's take a bullet to be our object 1, then the block to be our object 2. So we say, what is our m1? So in this case, we are talking about our bullet. What's our bullet? Our bullet has the mass of what? 0.0.01 multiplied by, what's the velocity? The velocity, we've been told that it was moving with 500 meters per second. Okay, so for now we can ignore the units, not necessary for now. Okay, okay, 500. What about this here? We know that this object wasn't moving, so we can just simply replace with 0 because the velocity is 0, so it will cancel everything out. So what about our m1? 0.01 multiplied by our v2, which we are looking for, v1, sorry, plus, what is our m2? Our m2, we've been told is 2 kg, which is just a 2. Then our v2 is what we don't have. Okay, so in this case, we don't have two variables, v1 and v2 we don't have. So if we multiply 500, let's simplify everything. 0.01 multiplied by 500, it's giving a 5. Okay, it's giving a 5, which is equal to 0.01 v1 plus 2 v2. Okay, so let's label this one as our equation 1. So that is our equation 1. Let's go to the other one. So the other one, where can we analyze? We want two variables here, so it is impossible for us to calculate our v1 and our v2 just from here. So we need to come up with something. Let's try to look at the situation after the collision. So after collision, we've been told that this object rises to a certain height here, which is 10 centimeters, of which we converted to meters, which is 0.1 meters. Okay, so we can say from this one, after it was struck, it was given kinetic energy, of which the kinetic energy was converted to potential energy at this position. So we can say m1, sorry, kinetic energy initial is equal to potential energy final. Okay, so our kinetic energy, which is just simply mv squared, is equal to mgh. So now we are talking about one object. This is the elastic the bullet had gone through, so it's more like it went through the block and came out, so it penetrated. So we can say we are talking about the m2. So the m2, we can cancel out the masses. Since we are talking about the m2, we can cancel out the masses. Okay, so then we make v the subject formula. So v the subject formula is equal to 2gh. So we can say the root of that. So our velocity, which was our final v2, so this is our v2. So our final v2 is equal to the root of 2 multiplied by 9.8 multiplied by 0.1. Okay, so our v2 is equal to, if you compute everything there, 2 multiplied by 9.8 multiplied by 0.1, so it's giving 1.4. So it's 1.4 meters per second. Okay, so we found our v2. So for now the question is saying the speed of the bullet just after it emerges from the block. So they're asking for the speed of the bullet, which is our v1. Okay, so now we found our v2. So it is now it's now simple for us to just replace there and find our v1. So 5 is equal to 0.01 v1 plus 2. What is our v2? Our v2 we have found it is 1.4. So here it is 5 minus, if we multiply that one, 2 multiplied by 1.4, it's giving 2.8. If we take it to the other side, it will be negative 2.8, which is equal to 0.01 v1. Okay, so if we subtract that one, if we say 5 minus the same one 2.8, it's giving 2.2, which is equal to 0.01 v1. So here, let me try to clear out some space. Let me create some space here. Okay, so let me clear this part. Okay, so we are saying it is 2.2, which is equal to 0.01. Okay, v1 over 0.01. We divide both sides. 0.01, which is v1 is equal to, if you divide that, you divide by 0.01. What is it giving you? Hope you have a calculator where you have. Okay, so it's giving 2 meters per second. Okay, so this is our velocity, or rather the velocity the bullet after penetration it went with. So it went with 20 meters per second. All right, that's all for this video. Kindly subscribe so that you won't miss out the next problem we'll be solving in another video. All right, stay safe.